What's up guys? Welcome back to Vanover Customs. In the last video you've seen us work on this gearbox and it's turning out really nicely. In this video we're going to be wrapping that project up and hopefully getting a reduced 2-speed gearbox for this tailstock. I got a piece of 3/4 inch plate right here, so we're going to get this thing cut up and start making that back piece. Let's get started. Let's take this chunky housing over to this plate and we'll get it marked up. Then we'll take it over to the hide mech and start getting it roughed out so we can start trimming this thing down. We went ahead and got the back plate finished up by drilling, counterboring, and then tapping the holes in the actual gearbox housing. I did that off camera because it's very similar to what we did on the other side, so it's pretty much just rinse and repeat. Next step is to go ahead and get this set up precisely in the milling machine, and then we'll be able to pick up both bores where the bearing housings sit and then transfer that onto this plate. So we'll meet you over the mill and start on that. We got the part set over here in the Bridgeport, and the next step is extremely critical. We want to make sure that our bores are in line for our bearing recesses. Now, if you're a gearbox manufacturer, you'd cast your gearbox and line bore everything to ensure that your shafts are in line. But because this is a one-off project, I think this is the best way to ensure everything is nice and in line. So I'm going to come in here and use the coaxial indicator and find both of our centers. And then we'll come in here and save both of those zeros using the absolute and incremental function on the DRO. Then we'll bolt the cap to the back and transfer those to the back cap. We'll actually make a small hole in the top, which we don't even need. And then we'll take the part out and then we'll have our holes located. In the bottom, our hole will be fine because we have a shaft going through it, but the top, our hole is just for locating. Once we're done, we'll actually weld that up so that way you don't even know it's there. Well guys, we got this machined and it turned out really nice. The surface finish on this side isn't ideal, but it doesn't matter, it's on the inside. It is nice and flat, which is what we want. We went ahead and welded up that hole that we didn't need on the top, and then bored out both of them and checked them with the snap gauges and the micrometers, and they're both within 5/10, so that worked out really nice. The other side actually looks a lot better. Surface finish is really nice. Didn't change anything. It's just a matter of I fed one way on one side and I fed this way on the other side, and it gave a really nice finish. Doesn't matter. We're going to be probably powder coating this anyway, but you've seen it here first. It looks nice now. It'll probably get scratched up just from handling it, but again, makes no difference. So now that this part is done, that completes the case and the cap. So we're going to start working on the innards of the gearbox. So working on the gears themselves, the shafts, and kind of go from there. It may not be initially obvious, but we are using a pre-purchased spline shaft here. I thought about making the splines myself, but with the time to set up the indexing head, I thought it was easier just to purchase one, and we're gonna go ahead and get this thing modified. It'll work out perfectly, and you'll kind of see why we're doing this as we move along. The main reason here is cutting the splines externally is not a problem, but we do need to make an internal spline part, and I wasn't able to do that with the equipment I have, so we ended up buying spline shaft and a matching female spline part and modifying those pieces to make it happen so that we can get our result. With the spline shaft modified, we're going to move on to making the top shaft. We're just using some typical cold roll I have laying around. This shaft is actually a mock-up. It doesn't matter at all. We're going to be making another version of this. So we're just making it as a placeholder until we can produce the final version. Here's a visual of the shafts kind of lined up. Here's the old shaft that was in the tailstock, and this is where the new shaft will start. And in the future, this will be one shaft. We have our thrust washer stack, and then behind there, we're going to have a little bit of the housing, 2 bearings, the large gear, and then another thrust washer stack here. And we'll use this collar to tighten up the tension on the thrust washers. We'll have just a spacer, and then our small gear, and then the bearing housing, and then moving to the bottom, our bearing in the housing, the small gear, our shifter selector, our large gear, a bearing support, and then this shaft will exit the housing with a handle. So that's kind of overview of how it works on the inside. Next step is to start working on the bores of the gears so that they match these shafts. And then we do need to install 2 keyways on this temporary shaft just for fit up, and then go ahead and broach those gears as well. So we'll start working on the gears and go from there. So we're ready to do some broaching over at the arbor press, and we got all 3 gears bored out to 0.875, and we have our Dumont bushing and 3/16 broach. And then off camera I made some of these hardened metal spacers, and they're about 1.2 thousandths smaller than the outside diameter of this. And the purpose for that is when we go to broach this, there's not a whole lot of meat on this gear, and so even though the broach keyway won't go all the way through, this will kind of add a little bit extra meat and strength. And as a side benefit, because this is larger than the gear, when it's pressed down, it's going to prevent these gears from passing each other. It'll kind of prevent that movement. So we'll go ahead and get these guys pressed on and start broaching. All right, we got our second gear. I'm not going to show you this process, but we're going to go ahead and broach this and then move on to the next step. We got our mock-up stub shaft done. The last step is just to mill off this part on the end. I added it as extra material in case we needed it, but we ended up not needing it. So let's go ahead and get that removed and move on to the next step. For the next part, we're going to come in here and cut our dogs on the indexing table. Instead of making this internal splined feature, I decided to buy a pre-made coupler. But as you see, the pre-made coupler I bought is a little bit thinner, so I turned up a sleeve and pressed it on. That's going to give us more meat for the dogs to engage, and later on it'll give us more diameter on the outside for our shifter fork to engage in. So let's come in here and get these dogs cut and see how we turn out. All right, this piece is turning out really nice. Off camera, I went ahead and messed this up. You may have noticed in the last clip, or you may not have caught it, but I was jumping in there just trying to get some milling done, and I realized I needed to stop, take some measurements, and then come back and try again. So I actually left extra material on here for us to fail, and we did, and we came back after I did some mock-ups on a test piece, and I figured out the exact measurements of offset, so that way this pie piece can be very similar in size to this one. Again, it doesn't need to be perfect because we do want some room in there for engagement. This isn't gonna be like a nice machine fit, but I do want it to be somewhat close, and I do want these teeth to have a nice meaty engagement and not be too thin or too small. And so this is where we need to be. So I'm gonna get this flipped over and repeat that on the other side, and then once we're done, I'll bring you back and show you the finished result. With the shifting mechanism complete, we can come in here and cut our dogs on the respective gears. We're gonna start out with the small gear and come in here and cut the dogs. And then once we get the dogs cut on this guy, we will go ahead and finish up on the larger gear. This is coming together really nice. You can see we have really nice engagement for the dogs coming together, and I designed this intentionally with a little bit of side-to-side slop just to make shifting the gears a little bit easier. I could try to go over there and dial in a 100% precise fit, but even though that's gonna look really good on paper, in reality it's gonna make trying to shift this in the actual gearbox quite challenging. So you wanna allow a little bit of slop. Now, if you look at a lot of like dog box racing transmissions, they actually have a lot less dogs or cogs, and that's to allow engagement quite a bit easier. But in this case, this is a slow speed gearbox, and instead of having less dogs, I opted for more dogs for more strength. The pro, aside from being more strength, is it's just going to allow more opportunities for engagement with less slop. So if you have big spaces between, you're gonna have a big area of play. And to me, it was gonna be more important to have a little bit less play when it's engaged and a little bit more strength, as opposed to just skipping like every other tooth and having it engage super easy, but to have a big play. So overall, very happy with how this is turning out. We're gonna make the other gear off camera with the teeth arrangement, because it's going to be much of the same, and then after that we should be ready to assemble and then just work on the actual shifting mechanism. So we'll go ahead and jam that other gear out. not gonna take much. Yeah, perfect. Didn't take much. This is the boss that we're making to hold our shift lever. I opted to do a bronze bushing as opposed to a bearing. It's a little overkill to be honest, but it'll give us a nice tight fit and it'll be nice low speed application, so a bushing works out perfectly. I'm actually gonna ream it by hand to final size, so that way our shaft is a really nice fit with about 1/2 thousandths of free play for movement. Moving over to the pacemaker lathe, we're starting on the shift fork. Now this part is unnecessarily machined. A fabricated part would definitely suffice, but hey, it was Sunday, I thought I'd have some fun. And with as good as this gearbox is turning out, I thought it would be awesome to continue the theme of really high quality parts. So I decided to entirely machine this from a large oversized billet, and we machine away like 90% of the part. So that way we're left with a really nice overkill shift fork. Our shift fork is done and it's turning out really nice. We got it installed with a custom shaft that's about 1/2 thousandths less than our bushing, and we got it installed. And you've seen I went ahead and made a brass follower off camera. So that follower fits in the groove and allows us to articulate this shift fork up and down. And so that'll help us engage both into the front gear and into the back gear itself. And this is a really nice way to convert linear motion into rotary motion and vice versa. That brass pad moves on an arc, but because it's extra oversized, it has the ability to move up and down without falling out of that slot. So this should work out perfectly. The next step is to make a handle for this shaft, so that way we have a selector knob. Let's get this tailstock moved out of storage, and let's get this gearbox assembled. Well, this is the point in the video where I need to be really honest. This gearbox has fought me, mostly at the end. We got everything assembled and it was going relatively smoothly, but here at the end, I just could not get this gearbox to not bind. Basically, I thought all my measurements were good and I double checked everything, but the reality is when I tightened up this back plate, I just had a bind. And so it led me down a rabbit hole of redoing stuff that frankly probably wasn't necessary. But nonetheless, we did make some alterations and improvements to the gearbox, mainly in the back cover, to try to resolve these issues. Later down the process, I learned that we had a bad thrust bearing, and that is where most of the binding that I was feeling was coming from, but I didn't figure that out until far down the process. The main change that you're going to see that we're not going to get into is I'm actually going to bore out the back 2 bearing caps and make custom bearing caps that have the ability to be adjusted. That's going to allow me to ensure that my bearing mesh or my gear mesh is accurate and that my shafts are in alignment. Once it's all done, everything is in alignment and it does work well, but we did have to do a fair amount of rework off camera to make this gearbox seamless. And believe me, I wasn't going to come this far and have this not work perfectly. So it does work dang near perfect, but we did do a lot of fighting off camera to make this happen. The other thing I'll say is we made this gearbox as an iterative process, mainly to see if we could do it and mainly for learning and having a good time. We could have easily did a CAD program to alleviate some of these issues, and that would have helped us out. But in the end, I really wanted to see if I could basically pull this from thin air, and we were able to do it, but with a lot more headache than probably was necessary. Retrospectively, a lot of the measurements that I thought I was off were probably fine, but I didn't figure that out until I had to make some other modifications and discoveries later down the road. And at that point, it just is what it is. So overall, I'm happy with how it turned out, but I wanted to point that out because it is reality of what happened. Okay, let me explain myself. I know a few people are going to be super confused. The bottom half of this tailstock, I wanted to add in what I'm going to call a chin. Basically, the gearbox hung past the tailstock, and so I wanted to add in a filler piece so that way it would look nice and seamless. This piece is 100% non-structural. It's just there to try to make the gearbox look at home and factory because the bottom of the gearbox will be flush with the back of the tailstock. Once it's done, you'll see what I mean, but this is definitely something you're not going to see every day. Well guys, after months of work, this 2-speed gearbox is done. It looks good, it functions good, and honestly, I could not be any happier. We have 2 different speeds available. We have our fast speed, and that does 285 thousandths of an advancement per revolution, so that'll be good for getting that quill in and out quickly. And then all we got to do is switch to low speed, and in low speed we have about 75 thousandths of advancement per revolution, which will be perfect for running big drill bits and doing anything where we don't want to be laboring over here on the wheel. And the nice thing is, in this mode, the ease of operation on the handle is even easier because it is a reduction. So this turned out great. Off camera, we went ahead and made a filler piece here in the chin so that this would look nice and factory, and we went ahead and just milled this surface flat and added a spot for a machinery tag that we're getting custom made. Overall, this turned out really nice, and I'm really happy with it. One other thing that I'll mention is on the back, which you can't see, I went ahead and machined a spot. We are going to be adding a DRO to this tailstock. So while I had the tailstock off and over at the K&T, we went ahead and machined that just while I was over there. So overall, the work on the tailstock is done. At this point, it's just going to be painting and finishing. Yeah, I'm really, really happy with it. I hope you enjoyed this 2-speed gearbox addition. It was a really challenging project for me. We made a ton of mistakes, but we learned, we grew, and we came out victorious. So next step is going to be to get this guy prepared for paint. If you guys have any questions, post them down below. We'll see you in the next one.